We're in section 10.2. We're finding the surface area of cylinders. And somebody tell me, what do you know about the base of a cylinder? What shape is it? It's the shape of a circle. So what do you think your formula is going to have?
Pi.
Yeah, pi. And it's definitely going to show similarities to your circle formulas. For example, 2 pi r squared. Well, if you take off the 2, isn't pi r squared the area of a circle? Right? And why do you think you're multiplying it by 2? Because there's 2 bases, right? A top and a bottom. So to multiply by 2, you're just accounting for top and bottom. So this part right here is for my base, and this part right here helps me determine the distance around the cylinder, because remember, this is surface area. So when we're looking at these cylinders, you guys I don't know if there was a blank. You'll have this? All right, it would be helpful if we were looking at a cylinder while I say this. So this blue part right here, that's the 2 pi RH. That's the second part of the formula that helps me calculate the surface area of the distance around the cylinder. And then the 2 pi r squared helps me calculate my bases. Okay? So we're always going to start with the formula, all right? Formulas are really important because you have to have them memorized and you have to know them in order to get the right answer. If you have even one part of your formula off, you really don't have a chance at getting the answer right, okay? So the formula is everything. Okay, let's say it together. S equals 2 pi r squared plus 2 pi RH, okay? 2 pi, 2 times 3.14. Now we have to be careful that we are looking at the value for the radius. What is the value for the radius on this cylinder? 4. Yeah, 4 millimeters. So what happens when I plug it in here? What's 4 squared?
16.
16. So everybody understand why I plugged in 16. Okay? You could absolutely do 4 to the second power, or you could just write 16. You could go ahead and do that math. All right, is everybody with me so far? So this math right here, guys, this tells me the surface area of the top part of my cylinder and the bottom part of my cylinder. All right, so I'm finding the surface area of my bases. What is 2 times 3.14 times 16? Anybody got it? Hadley? Yep. Oh, sorry. Okay, we'll get to that in a second. But yes, you are right, 50.24. All right, so now let's take this. Remember, this is our lateral space. So the distance here, okay, the surface area that covers all the way around the cylinder. Okay, so 2 times 3.14 times the radius. Notice in this part I don't square the radius, so I just plug in a 4, times the height of the figure. Okay, and that will give me the surface area of that space around the cylinder. Okay, so going off what Hadley said, my first one, oh, remember we have to double it. Okay, I got 100.48 when I did, no, that's not right. 32, yes it is, okay. 2 times 16 is 32. 32 times 3.14, I got 100.48. Okay, now we multiply this side. Calculators are okay. What do I get when I multiply 2 times 3.14 times 12? Isla?
75.36.
Yep, that's what I got. And now I just add those two together. 175.84 millimeters squared. And technically it's approximated even when the answer doesn't look rounded, because why? Why is my answer always approximated here? Because of pi. Pi is a rounded number. Okay? I will not take off for that, but technically that is correct to estimate it. All right, so let's go ahead and do this second figure. Same formula, okay? You're just plugging in your numbers into your formula to find the surface area of the cylinder. And go. All right, and once you have your answer, raise your hand. Compare your answer with your neighbor. And we'll work on it. Plug our numbers into the formula. And we do the math. Wait a second. Where did I get? Let me just finish writing these in. Where did 9 come from? I don't see a 9 anywhere in those dimensions. Hannah?
3 is
Very good. We recognize that we have to square the radius, right? That's in my formula. Okay, so when I plugged in 9, I was doing 3 squared. All right, very good. So now when I multiply everything and I add them together, I got 395.64 centimeters squared. Got it? All right, so I saw most of you had that answer, so great job. All right, so this is surface area of a cylinder. This is bases and our lateral surface area, which is around. Now, in example 2, it's almost a step back from what we just did in example 1. Because now in example 2, it only wants to know the lateral surface area around a cylinder. So I am no longer including the bases. So you just have to be careful on the instructions. If it says find the lateral surface area, you will not include the bases. Okay? So that takes out that first part of your formula. You don't have to do the 2 pi r squared. Okay? So here we go on example 2. All right, so it's only the lateral part of my formula, 2 pi RH, the second part of my formula. That's what tells me the amount of space that it takes to cover around a cylinder. And then I just plug in the numbers. So it's almost like just less substitution. You just have to know, you have to be able to recognize what it's asking for. So 2 times 3.14. Okay, what value do I plug in for radius?
4.
4? I don't see a 4 in there. Where'd you get 4? Yes, so 8 is the diameter, so I half it for 4. And then to get 4. And then 5 I plug in. And then I just multiply the numbers together. I know it's going to be, it looks like 40 times 3.14. I got about 125.6. Okay, does everybody see the difference between example 2 and example 1? Okay, all right, so go ahead and do that second one. We're going to do this one and then one more example and we'll be done. All right, so 2 pi RH, so plug in 1.5. You guys did great. I saw a lot of 1.5s. Even though it gave me 3, you recognized that that was the diameter times the height, which is 8. And then when I did all my multiplication, I got 75.36 yards squared. All right, how'd you do? Okay, so the modeling real life is kind of interesting today. All right, so I'm going to take you through it probably once or twice. All right, just try to follow along with me. A lot of it I'm just going to have to kind of show you. But here we go. Okay, the iced tea can. Has anybody ever drank canned iced tea?
What?
Really?
I don't like it. I don't like iced tea.
Okay. All right. So, hey, this is right up your alley then. Okay. The iced tea can is made from a sheet of aluminum. You guys know that, right? So, like, if you cut it up, you could actually cut yourself. Has anybody ever cut themselves on, like, a bottle cap? Yeah, you can. It's aluminum. It'll cut you. All right, I'm getting sidetracked. Okay, everybody look up here. Okay, the iced tea can is made from a sheet of aluminum that weighs 0.01 ounces per square inch. Okay, so you receive 40 cents per pound of aluminum that you recycle. So how much do you earn for recycling 24 cans? Well, I know how much I'm going to make per square inch, but can I just look at that can and say, this is how many square inches it is? I just know it? but do I have a means of actually figuring out my total square inches around that can? So that's what I'm going to do first. Okay, so I've got my formula, 2 pi r squared. Okay, so that does not look like a decimal. Let me fix that. 2 times pi, that should not be 3.14. Y'all should be writing this down. Okay, times my radius, which is 1.5 squared, plus 2 times pi times my radius times my height. So this is nothing new. We've done this in example 1 where we're trying to find the surface area of the can. Okay, if it tells me how much I make per square inch, it makes sense that if I know how many square inches, I know how much money I can make off of 1 can. Y'all following me? Okay, so when we do all this math, all right, I want to give you a minute to do the math and figure out how many square inches of aluminum are on this can. Okay, so I got about 80. About 80. Okay, so just round it to 80. Okay, so for 1 can, it's about 80 square inches. Okay, so now at this point, you really have 2 options, and I'm tempted to kind of go a different route than I even went in 4th hour. There's not just one way to figure this out. Now look what it says. Now I'm going to do the same way that I did. How much would you earn for 24 cans? Okay. All right, so if I know how many square inches are in 1 can, okay, could I figure out how many square inches are in 24 cans? What could I do? I can multiply them. 24 times 80. That's going to give me my total square inches for all of my cans. Okay. Did y'all get 1920? Okay, so that is the square inches for all 24 of my cans. Now notice, how much do they weigh per square inch? 0.1. So I can take all my square inches and multiply it by 0.01 to figure out how much these cans weigh. How much do all these cans weigh? 19.2 ounces. Well, this problem would have been very easy to finish solving if they had given me a price per ounce. But what did they give me? A price per pound. So I need to convert 19.2 ounces to pounds. Yes. How many ounces are in a pound? So you can divide, okay? You can divide whatever number it is. Now, I know this is going to be more than 1, right? 19 is more than 16. You can divide by how many ounces are in a pound. And that will tell you how many pounds is equivalent to 19.2. All right, you see how I'm saying, like, I'm just going to have to tell you, but maybe next time you could do some of it. So what is 19.2 divided by 16? 1.2. Finally, this is how many pounds. I calculate all my square inches, and I know how many pounds of can aluminum I have. And now I can multiply that by 0.4. That tells me, okay, because it's 40 cents per pound, but I know I have a little more than a pound. So how much money did I make for all my work?
48 cents.
Whoop-de-doo. Okay, so if you're thinking like me, you might be thinking like, I'm not doing all that for 48 cents, but it really can add up. If there's somebody in your family who's like an avid soda drinker, you know, it can add up. Okay, so, well, Jack, what did you just say? Samuel? He said 1 can is How did he figure that out? So now, okay, now that I know that each can is 2 cents, could I scale it? Could I like totally scale it? You know, so if I turned in 100 cans, I'd make $2. Here's your $2. Well, yeah, but I mean, what else are you gonna do with them? You know, just throw them in the trash. You can recycle them. All right, so that's everything you need to know for 10.2.